Oh, so we can't hear you.
Morning, everyone. I'll be right there. Good morning, everyone. How are you today? My apologies, a couple minutes late here today on a Monday. A lot of things going on here. Give me a minute for everybody to get their cameras up. So I'm back in my old office here. It's rather hot here, as you can imagine. So we're maybe getting the a hurricane midweek, so maybe quite rainy. All right. 1 second, I'm trying to print something out here. There we go. Okay. So obviously, thank you everyone who did the exam. Everybody did really well, right? The average on the exam was a mid-80s. So you guys really thumbs up. You guys knocked it out of the park. Did a great job. Okay. There are a few people that haven't taken it yet. Okay. So they'll be taking a makeup. So probably Lucas or myself will be able to go over exams with you probably midweek. So stay tuned for that. But again, you all did a really good job. Really good job. So very impressed with that. Okay. So as you know, Lucas sent out stuff to help me with the introductions. I want to try to, again, the introductions is an important part of this class. It was I want to have people to be able to do things and get things ready to go. So there is a list here of who's going today. So we're going to do a couple of introductions right now. I don't see, let me see, I don't see everybody here. Yeah. Okay, so let me get my list. So we're going to start by doing that. So Hugo, you didn't go, so you can go first.
Sure. Let's go ahead and pull it up.
Go ahead, anytime you're ready.
Sure. So you can see my name's Hugo. I live in the south of Spain, so on the southern tip. I don't know if you guys have heard of Gibraltar.
Which one?
Gibraltar.
Oh yeah, sure.
Yeah, so to about 30 minutes to the right, up on the coast from there. And before that, I lived in Westchester, New York.
Okay. Yeah, I was gonna say you don't have a very strong Spanish accent.
No.
A Spanish accent. As I didn't.
I'm half Spanish, half French, but I grew up in New York.
Really? So Rochester, New York, out near Hobart, out near where I went.
Westchester, yeah, Westchester, New York.
Oh, Westchester, New York. I thought you said Rochester. So no, so you're just outside the city.
Yeah, just outside the city.
Got it. Okay, great. Okay, so what have you been doing during this COVID stuff?
Aside from classes and studying, running, sailing, working out, just as much as you can do while trying to be safe.
Yep.
But also taking care of yourself physically and mentally.
So what do your parents do? So I'm assuming you must be in Spain because one of your parents works there.
No, about 5 years ago we moved to Spain, and I finished high school here in Spain at an international school. So we have a place here, and so this is kind of like where we live. It's a little weird because we're a family of three, yet everyone's spread out around the world. I have my sister in Zurich who's doing her master's. I'm in Boston studying for college, and my little sister's still here in Spain for school.
Wow, isn't that fascinating?
Yeah, so obviously my mom's here because the little one's still finishing school. She's a creative director at a company she started, a home linen shop. So far it's online for the European market.
Wow.
And then my dad's a managing partner at a private equity firm.
Oh, good for him.
So yeah.
That's great. So are you coming back to Boston in a few weeks, or are you going to be remote for the fall?
No, I'll be coming back a couple days after finals for this summer session,
Good for you.
and
Awesome.
or hopefully, knock on wood. I really hope that
No,
flight doesn't get
again, I think
canceled.
a lot of students have reached out to me. I think I mean, certainly BU is doing everything in their power to make it as safe as possible. I think obviously the environment of what other people do, and obviously how well the students do in policing themselves, is really going to be what it is, right? I mean, if students start disobeying kind of the rules, and I know they want to get to socialize and be together, but if they start going having parties off campus, and are not careful, and numbers get too large, I think that's going to be that's a recipe for disaster, and that's kind of out of BU's control.
Absolutely.
So
So the two truths and a lie. I broke a Guinness World Record. I've flown a plane, and I've performed in a music festival in front of thousands.
cool. All right, so gosh, you got to tell it. So is the first one true?
Yeah,
So what
yeah.
Guinness World Record? Guinness World Record what?
Back in 2010, it was the biggest torchlight parade, and we did it in upstate New York in a mountain, skiing down.
Yeah.
Couple thousand people.
Awesome. What mountain was that? It wasn't Hunter.
Wyndham.
Wyndham. Okay, I don't know that one. Awesome. Good for you. So which one's the lie?
Third one. I was supposed to perform in the music festival, but they canceled it last minute.
Oh, so what do you play?
Um, well, I really like music. I really enjoy it. So I try to push myself to learn a bunch of instruments. So
Yeah.
from piano, guitar, violin, harmonica is a really cool one.
Good for you.
Yeah.
I mean, again, you can't really see, but a bunch of instruments behind me, but again, it's been a long time. I'm hoping to get back into it, and maybe I will. We have a couple-week break before school starts. Maybe I'll get back into it again for the fall, but we'll see. So we'll go. Well, good.
That was
Well,
a pretty good time.
yeah, it's fun. So yeah, so it's a great outlay. So thank you very much. Appreciate you introducing yourself. Okay, so yes, let's go to somebody else. Jishuan Shi. Again, my apologies. I'm not sure I said the name correctly. Is she here? Oh, she might be here either. Well, that's the problem. People offer to do online, in-person recordings, and I don't see anybody here. Oh, Dimitro, you didn't go already? Oh, all right, you're up.
Yeah, okay. So my name is Dmitro. I'm 18. I'm second year computer science student. I live in Ukraine, in a city called Lviv. It's about 350 miles away from Kyiv, our capital. Yeah, my mom is a marketing teacher in a university, and my dad is like a director in a IT company here in Lviv. What else?
So wait, I got to ask you. So Ukraine, why are you coming to BU?
Well, my grandparents live in America, and I was supposed to go in America this summer to visit them, and so like not to waste time, I selected this summer school, like this course, and I was supposed to be on campus, but unfortunately this coronavirus stuff happened and I didn't.
So is this one of your first classes at BU?
Yeah, it's my first one.
This is the first one?
Yeah.
Oh my gosh, I'm honored. Thank you so much. Your first experience was a Parker class. Oh my God, God bless you. Well, if you survive me, I guess you're going to be all right. So welcome. Well, that's great. That's very fascinating. Okay, so obviously, so again, I don't know much about Ukraine, but what's the COVID like? I mean, is it serious there? Is it not a big deal? What's going on there?
Well, like half of spring, it was like okay, but then we had this quarantine, and it was like the restrictions were loosened somewhere in the beginning of summer, and now we have like some of the restrictions renewed because we had like this.
You had a resurgence in cases.
Yeah.
Like we have in the United States. Yeah.
But I think that they will be loosened again somewhere closer to autumn. Yeah.
Okay. Awesome. So two truths and a lie for you.
Okay. So first one is I had a car accident the day after I got my driving license.
Oh God.
Second one, I actually had COVID in spring. And third one is I had a 700-mile trip on a bike with my friends. Yeah.
Bike as in a bicycle?
Yeah.
Wow. Okay. So I'm assuming you have had COVID?
No, yeah.
Oh, thank goodness. Well, I have had a few students that have had it. So, I mean, it's not, I mean, thank goodness it's not a common thing, but you know, it has happened. So, well, that's good. Well, thank goodness that's a good thing. So, so you've done a bicycle trip. How long did that take you?
We drove from Lviv to Kiev, our capital. It's like 350 miles away. So one way it was 6 days, and way back it was 5 days. We traveled like 60 miles, roughly 60 miles a day.
Yeah, that's good. That's really good. Yeah, as I've told everybody here, I've been doing a lot of biking myself the past, well, you know, several months. I've always been a big one, so I'm pretty good now. I'm doing somewhere between 20 and 40 miles a day, depending. I don't know if I'll get out today or not because it's gonna be hot. But I mean, I have been going, you know, definitely 4 or 5 times a week. So I've been doing several hundred miles a month. So that's great. Good for you. Well, gosh, well, welcome. That's very fascinating. So are you coming to campus in the fall or no?
I'm not.
Not yet. So are you gonna be doing remote stuff?
Well, I'm studying here in Lviv. I just took a course like for myself.
So
I was assuming that I was coming to Boston this summer.
Right. Okay. So you're not sure you're going to be enrolled at BU? Is that what you're telling me?
No.
Not sure. Oh, well, that's too bad. Well, gosh.
I'm studying in like this Ukrainian Catholic university. It's like Catholic, not because we sit there and pray. It's like financed by like Ukrainian diaspora in America. So like we have like this this principal. He's American, right. So we have part of America here too.
Right. So you may get kind of sponsored to go to school there. Wow.
Yeah.
That's great. Oh, congratulations. That's wonderful. Okay. Well, thank you very much. All right. Let's do one more, and then we'll go start our lecture for today. Oops. Where's my? Oops. Sorry. I'm missing my Outlook. Oh, there it is. All right. Who else is here? Haoxuan Song?
Yeah.
There? Oh, there you are. Great. Sorry, I mispronounced your name, but okay. Tell us about yourself.
Hi, everyone. My name is Song Haoxuan, and you can call me Jim. I come from China, a small city called Langfang, which is next to the capital, Beijing. And I'm a rising sophomore. I'm just transferring to questrom from CAS. And my parents, so my mom already retired, and my father is working in a private equity firm in China. And about COVID-19 in my hometown, because I was in the United States for the entire summer, so I didn't have the chance to go back home, so I don't know what's really going on over there.
But so where are you now? Are you in Boston or in China?
Oh, I'm in Boston now.
Oh, I see. Okay.
So, but what I heard from my parents is that the COVID-19 is pretty much over in my hometown, and people start to getting back to their normal life.
Yeah.
Yeah. And three fun facts about me is I went to Singapore for high school, and I'm a big fan of Stephen Curry. And the last one is I made over $5,000 in the stock market last month.
Really? Boy, good for you. Okay, so which one's the untruth?
The last one.
Oh, yeah. Well, again, kind of. I mean, certainly, if you do some smart investing these days, again, I'm sure the companies that do the tents so that you can eat outside, I'm sure that's a very big business. Certainly, healthcare, anything to do with COVID is going to be a big business. Certainly, delivery services is a big business. So there are industries that are certainly burgeoning in this pandemic. But wow, that's interesting. So, are you just staying here to go to school in the fall, or are you going to go home?
Yeah, I'm just waiting for the fall semester. So I'm planning to return to campus.
Good for you. Good for you. So you have an apartment in town in Boston?
No, I just using Airbnb to rent an apartment.
Really?
Yeah.
Wow, good for you.
Month.
Good for you. Okay. All right. Let's see. Anybody else here? All right. They're missing some people there. Okay. Well, we'll start class now. And if your schedules go on another day and you want to go today, then go today. Because again, I want to try to get these done for everybody. Again, they are part of your grade, right? It's a part of the interaction, shows you know how to do this thing. Again, many of you, this whole Zoom platform may be something that you may end up doing for your job, right? So, it's a whole new way of kind of interacting, and this is a good way to practice, right? So you may need to, figure out a way to introduce yourself over Zoom to somebody, or you may be even interviewing somebody for a job over Zoom. So you gotta make sure you feel very comfortable with this platform and know how to do it. So that's great. Okay, so let me have a sip of my coffee here. And we're going to talk about our topic for today. So basically, we're starting our last section. We're in the home stretch now for this class. The last third, because it's been 2 weeks, last 2 weeks here, we're talking about hypothesis testing. And this is kind of the big culmination of everything we've been doing up until this point. This is a great topic. I love this topic. It's kind of very important to do, and it's a good one to know. Virtually every day we're going to deal with hypothesis testing, so it's going to be definitely the topic. We're going to do different variations of it and things on it over the next couple of weeks. So we have class, Monday through Thursday this week, no class Friday unless we need it. Again, be maybe a workshop day, and then we go next week. Again, next week's a short week for us because we have class Monday, Tuesday, Wednesday. Final exam is then going to be that Thursday. Okay, so we're wrapping things up pretty quickly here as we go forward. As I mentioned last class, I am teaching. It looks like my schedule for the fall has changed a little bit. I am actually going to be teaching two sections, and students want to know, oh yeah, gee, when are you teaching? I'm teaching a 9:30 in the morning and a 2 o'clock in the afternoon. So if any of you can join me in my class, love to have you. Again, you kind of know my quirkiness things already, so I mean it could be a good and a bad thing. So some of you may want to join. Some of you may say, heck with it, I want to get out of here. That's certainly fine. My teaching style is not for everyone. I understand that. So that's perfectly fine. Okay. Okay. Bo, I will have you go a little bit later in class. Okay. All right. So let me bring up my PowerPoint here. Okay. So 1 second, I'm trying to get everything all going here. Trying to move all these screens away. There we go. There we go. Okay, let me share my screen with you. There we go. Okay, everybody can see the PowerPoint? Thumbs up? All right, thank you very much. Okay. All right. So hypothesis testing is probably a phrase you've heard about before. Certainly if you've done things in science, a lot of the sciences do a lot of hypothesis testing. So a hypothesis is where you're alleging that something is happening. You're alleging that, that if you throw a ball, it's going to go so far before it drops, and you're going to do some kind of test for that. In mathematics, or what we're going to statistics, is we're going to allege that that the mean of a group of people, that the number of with the obesity problem in this country, if not the world, we're saying people are eating too much, So we're going to allege that people eat more slices of pizza than they used to, right? So that'd be a hypothesis that people are eating more pizza than they used to. So we either prove or disprove that. We may want to, again, it's been shown through biology and genetics that, these days average height over the past 200 years has increased, right? So, I'm about 6'1", 6'1", but average height, 100 years ago was below what it is now. And I think the average height for male now is about 5'10". I think 100 years ago it was like 5'8". Okay, so a hypothesis is that the average height of humans, males perhaps, has increased the past 100 years, and then you do something to basically prove or disprove whether that happened. Okay, so with hypothesis testing, the basic problem is you're interested in deciding whether some data, whether you're going to credit or discredit some kind of hypothesis. Usually it's a statement around a parameter, most often the mean, right? So if the mean is unknown, then you've got to know something about it, okay? So what we do is, this is the way we formulate a hypothesis statement, okay? So what you see here, this is the main part of what you're going to do, okay? Now, we're going to learn today, hypothesis testing is not that hard, okay? It is subject to a bunch of rules. And if you follow those rules, you'll never get lost. And you'll also get it right, okay? I'm gonna lecture about this with this PowerPoint. And in addition, I'm going to give you a Word document. I'm going to show that in a few minutes. A Word document that I put together that basically has the rules of the road. And basically it'll hopefully help you understand hypothesis testing. Okay, so what we have is we have this letter H, and then it's sub 0, and then we have the other ones H sub 1. Okay, so we refer to that as HO and H1. HO and H1. If you've had stats before, the second one, the H1, you may have done that as H sub A with a little A next to it, which stands for the alternative hypothesis. That's fine, right? You can use either one. In this class, the notation I'm going to use is HO and H1. So whenever I do a problem, that's what I'm going to do. But if you know HA, that's fine. Okay. HO is called the null hypothesis. This is what you're trying to assume is happening, the null hypothesis. The reason it's called the null hypothesis is because that's 0. HO is 0 in mathematics is called the null, right? So HO, also known as H null, shortened null, is the null hypothesis. H1 or HA is known as the alternative. It's the opposite, right? So HO. So if HO, you think that the average is equal to something, H1, you say it's not equal to something. Okay, so they're kind of opposite directions. Okay, so what we may know is we may know something about HO and H1. So let's say, again, it doesn't matter what the problem is. Let's say we're thinking the average weight. The average weight of a refrigerator. Average weight of a refrigerator is 160 pounds, right? And so we say, okay, we're suspicious that the average is 160, okay? Or maybe the average is not 160. So we're gonna prove either it is 160 and not 160. Now the key thing to understand right here, the key thing to understand with hypothesis testing is we're trying to prove whether it's true or not true, meaning we're doing yes or no. With this statement, we want to know, is the weight of this refrigerator 160 or not 160? We're not saying, oh, it's not 160, what is it? That's not what we're doing. It's either 160 or not 160, period. Right? 160, not 160. If we actually think that the average weight of this refrigerator is 150 pounds, that is a new test. You would then do type HO equals 150, H1 not equal to 150. Everybody follow me? Again, so if you're here watching, please unmute yourself if you have a question. Okay, so we must make a decision whether to accept HO or reject HO. Except, again, we want the null hypothesis. The null hypothesis is the main thing we're talking about. So we're trying to either prove the null or disprove the null. I'll say it again. We're trying to prove the null, HO, or disprove the null, HO, right? You really don't do the H1 or HA, the alternative hypothesis, is kind of thrown in there, but you never really talk about H1, right? It's just in there to tell you what the alternate hypothesis is, but you don't make any conclusions about H1. You do not make any conclusions about H1. Okay, so how do we decide whether to accept HO or reject HO? Well, what we do is we look at X bar. So in other words, what we're going to do is what we're saying is the average weight of these refrigerators, all these refrigerators, it's a specific brand, right? It's the Parker brand. It's the Parker brand refrigerators, right? We say they're all weigh 160. We're talking about all the ones, right? So obviously it'd be too difficult to weigh every refrigerator. So what we can do is we can take a sample. Again, this is what we did last, a week ago, right? We took a sample, okay? And from the sample, we can then make some conclusion about the population. Again, it's very similar to what we did when we did the confidence intervals, right? Confidence intervals, we said, oh, we want to know, how many chickens, the average number of eggs that these group of chickens will lay, right? We did that, right? So we took a sample of 20 chickens, found out they all laid, roughly 3 eggs a week or 3 eggs a day. And from that, we included, okay, it looks like they all lay 3 eggs away, right? 3 eggs a day, right? So that's what you want to talk about. Okay, so basically what we're going to do is we're going to use the sample and make some kind of decision about the hypothesis. Okay, so again, HO is equal to 160, H1 mu, the average is not equal to 160. So even if mu is equal to 160, X bar can never be able to X6 to 160, right? I told you that. So remember, a sample mean can never really be the population mean. Why? Because the population mean is all the values, meaning you're weighing every single refrigerator you've had, okay? And it may be very impractical, if not impossible, to weigh all the refrigerators, right? And so you always know, again, my example for this is if you were a room full of 50 students and we had a way of measuring your height. So we measure your height as you came into the room, all 50 students came to the room, we measured your height, We calculated your mean. Your mean is whatever it is. Then if everybody left the room, and everybody came back but one person, everybody, one person came back, right? So taking the average of those 49 people will never be exactly the same as what it was for 50, right? It can't be. Mathematically, it just doesn't make sense, right? Again, well, you say, oh, wait a minute, what about the 50th person if the average was 5'10" and the 50th person was 5'10"? Okay, but I mean exactly. I mean 5'10.000, whatever it is, right? It's never going to be exactly the same, right? So therefore you can't accept HO only if X bar is exactly 160. That's silly. So what we do is we accept HO if it's near 160, right? And if it's far away from 60, we reject HO. So really, the point we're trying to do with hypothesis testing is a little subjective. I'm going to say that again. It's a little subjective. It depends. It depends how close is near and how far away is far, and to determine whether something is what you expect. Okay, so the basic logic is the following. Okay. So again, HO and H1, mu is equal to 160, mu is not equal to 160. So if you assume HO is true, right, the true average is 160, we want to find the probability that X bar would be that far away to be that HO is true. So if the probability is small, we reject HO. If it's not too small, we give HO the benefit of the doubt. Okay? So in other words, I'm going to show this example in a minute, but if you say the average of these refrigerators is 160 pounds, if you sample 100 refrigerators and you find the average weight of those refrigerators, those 100, is 159 pounds, you would probably say, yeah, 159, that's pretty close to 160. So yeah, we can say the refrigerators weigh 160 pounds. On the other hand, if we measured 100 refrigerators and we found the average was only 120 pounds, oh my gosh, 120 isn't anywhere near 160. So, something's wrong. Parker, your refrigerator company, you're alleging they weigh 160 pounds. They don't weigh 160 pounds. You're way off, because the average of 120 is very far away from 160. And again, far is, determined. So the issue is, what if I get an average of 100? What if I get the 100 and the average is really 148 or 151? Well, 151 is not near 160, but it's not really that far away. So again, that's a nebulous area, right? So that's where you've got to decide, okay, well, it's not right on, so it's not a clear cut, oh, that's definitely accept HO. It's not really far away where you say, oh yeah, you got to dismiss HO then. There's no way that's the way it is. But if it's kind of close, well, how close is close? And that's where we have to make a decision about what to do, and that's going to be the process that we are going to evaluate right now. Okay, so essentially, we need to assess what's small and not too small. Okay, so essentially, you're going to decide, right? It's going to be decided for you, right? So what you may do is you may pick a value of alpha. Okay. Now, we know alpha. When we've done our confidence intervals, we wrote 95% was 1 minus alpha of 95. 99% confident was 1 minus alpha of 99. Okay. So with 95%, 1 minus alpha is 95, then therefore alpha must be what? 0.05. 1 minus 0.05 is 0.95. For a confidence level of 99%, 1 minus alpha is 99, alpha must be what? 0.01. So really alpha. So alpha is known as your significance level. Alpha is known as your significance level. So let me just pause here for a second, go to the document camera. And I just want to show that to you. Let me turn on my document camera right here. Okay. Let me get my document camera kind of set up here so it kind of works. Get the light on here. All right. That's your 1 minus alpha. This is alpha divided by 2, right? Because of what? Because of symmetry. Okay? So alpha divided by 2. So really what we're going to be looking at in right now is we're really going to be looking at this area here. For hypothesis testing, we want to look at the area in red, which is known as your significance level, significance. Right? So that's really what we're going to be talking about.
Professor?
Student?
Could you check your document camera? Am I seeing the color wrong or?
Yeah, it didn't the color didn't come out right. Let me see what's happening. Because you can't see that as red, right?
Yeah, it's
black and white.
Yeah.
Yep, give me a second here. Oh, that does that thing. There we go. That better?
Yes, it's normal.
Thank you. Again, in my travels home, I had to redo all my paraphernalia here. Obviously, one of the buttons got pressed when I was put in here. Okay. All right. So that's what we're going to be. So this is what we're going to be talking about significance, right? And significance is always going to be referred to as alpha. It's your significance level. Okay. All right. So let me go back to the PowerPoint here. Okay. All right. So sorry, I didn't take off the share, so I'm sure you just saw that little thumbnail thing. Again, I'm probably gonna get used to my office again with all the different monitors I have. Okay. So again, you pick a value of alpha, most often 0.05. And again, 0.05 should make sense to you. Why? Because I told you before that if your confidence level is not stated, it's always 95%. So if your confidence level is 95%, therefore your alpha is what? 0.05. So again, if your significance level is not stated, it must always assume to be 0.05. So again, your confidence levels assumed to be 95%. Alphas always assumed to be 0.05%, always, unless you're told otherwise. Okay. Much like I did before, I said, okay, your confidence levels. Your confidence levels are generally 90%, 95%, 99%. We did, again, that was that sheet I had before when I showed you about the confidence levels, okay? Occasionally, maybe 80%. Therefore, the alphas, meaning significance level, again, are going to be easy. It's basically going to be a few of them that you do. It's going to be 0.01 for 99%, 0.05 for 95%, 0.10 for 90%, and 0.20 rarely for 80%. Right? But generally, it's going to be those. It's going to be basically those three, maybe four. Right? So it's going to be pretty simple once you kind of figure out how to do this. Okay. So going back to this PowerPoint, you pick a somewhat arbitrarily a value of alpha, most likely 0.05. Great. Same thing with it. If the probability of X bar being as far away from HO value of mu as it actually exceeds alpha, then we say the chance of getting what we got is not that small, not that inconsistent. right? The difference could be due to sampling error. So we would accept HO. Now again, this slide, a lot of verbiage on here. I get it if you're like, what the heck, that slide doesn't make any sense to me. I'm going to explain it in a little more detail as we go forward. Okay, so if the probability of getting what you got is under alpha, we say the opposite. Forget about it, right? Under the HO assumption, the chance of getting we get that small is coincidence. So basically here is we're going to reject HO. We're going to reject HO. So your conclusion about hypothesis testing is going to be accept HO or reject HO. And again, I say again, remember we're making a decision about HO. We're not talking about H1 or HA, right? We're either going to accept HO or reject HO. Accept HO or reject HO. Okay, here's an example. Suppose that we want to test if a coin is a fair coin. We decide to flip it 100 times. Okay, this is my example I just said about the refrigerator. Another example like the refrigerator one I just did. Okay, so here we're saying, okay, if the probability of getting heads is equals the amount of times you get tails, the coin is fair. Okay, so what we're going to do is we're going to flip it 100 times. So this is interesting. So in the first case, if we flip it 100 times, if we get 49 heads, arguably that everybody would probably agree that makes sense, that truly the coin is fair because we expected 50, we got 49, that's very close. The second case, if we get 81 heads out of 100, that's probably suspicious. That's like, oh my gosh, that doesn't make sense that that you get 81. Okay, that seems very far. So that's so far away from 50% that you probably I don't think that's a fair coin. Something's going on. It's not equally becoming heads and tails. But again, the third case is that one I said if you take the sample of 100 refrigerators and you find the weight between 148 and 150, what's that mean? Well, the third case, if you get 60, well, 60 is not, I mean, it's not 50, but how far away from 50 is it that you really consider that? So we're really not sure to about 60. So therefore what we do is what is the chance, the probability that what is the chance that if it was indeed 50, how likely is it we would have got an answer as much as 10 flips away from 50? So if this probability is less than alpha, we reject HO. If it's greater than or equal to alpha, we accept HO. Right? So that's basically what we're going to be doing to make our decision. So since alpha is always small, again, alpha is either 0.01, 0.05, maybe 0.10. That's still relatively small. So HO gets the huge benefit of the doubt, and H1 gets the burden of proof. HO gets the benefit of the doubt. Okay, so let me talk about hypothesis testing theoretically. If you are familiar with the judicial system in this country, right? In this country, so it's not this way. It's not the way in all countries, but in this country, if you get accused of a crime, you are quote unquote innocent until proven guilty. Innocent until proven guilty. So therefore, what happens in a jury trial, it's not so much, excuse me, the presumption of innocence is how you go in, meaning you're presuming that HO is true. So unless, in this country for the judicial system, unless you can prove beyond a reasonable doubt that somebody actually did the crime, then you got to assume they didn't, that they didn't do the crime, right? So again, reasonable doubt. So what that means is, excuse me, if somebody is accused of robbing someone's house, right? If you can't prove beyond a shadow of a doubt that this individual actually did this crime, broke into the house, stole these items, etc., even though you may be suspicious the person did it, if you can't, if you can't prove it, then the person's going to be presumed innocent and not going to be charged. Okay, so that's what HO. So HO in mathematics always gets the benefit of the doubt. You always assume that that's what it's going to be. Okay, so in this country, the judicial system, you're presumed innocent. So therefore, the burden of proof is H1, meaning you really need to prove beyond a doubt that H1 is so far away from HO that, oh, there's no way that could happen. You got to reject HO, right? So I'm going to say it again 3 times. HO gets the benefit of the doubt. H1 has the burden of proof. HO gets the benefit of the doubt, meaning HO is always true unless you really prove it's not. So therefore, H1 has the burden of proof. H1 is the one that you really need to have happen. 3rd time, HO gets the benefit of the doubt. H1 gets the burden of proof. Going back to the judicial system in this country, again, with a jury trial, okay, when the trial is over and the jury gives a verdict, they basically say whether or not, the person did the crime or not, whether the person did the crime or not. Well, what do they say? Well, they come back and say guilty, meaning the person did it, or they say what? Not guilty. They do not say innocent, right? If someone is accused of doing something awful, someone accused of murdering somebody, horrendous, right? If the person is not convicted, it is not, oh, you're innocent. It's you're not guilty. Not guilty does not mean you didn't do it. Not guilty does not mean you did not rob the house. Not guilty means there wasn't enough proof to prove that you did rob the house or that you did murder somebody. Again, sorry, it's a rather morbid topic. My apologies. But again, that's what it means. So not guilty does not mean innocent. Likewise here, right? Saying something is rejecting HO doesn't mean that it doesn't happen. Okay. So essentially then what we're looking at, excuse me. So essentially what we're looking at is this graph here. So what if we know, this is something else. This is not the, okay, so we want to, what if the sigma, we know sigma is 20. We're going to sample 16 things, right? And we choose our significance level to be 0.05. Again, it's 0.05 unless you say otherwise. So we find the region similar to, but not the same as, the confidence interval, such that outside the region contains alpha. So essentially what we're finding out is we're finding the confidence level, and if it lies outside the confidence level, we say that's too far away to, that's going to cause doubt. HO is going to be false. Okay, so what do we then find then is we basically find, again, this way we find about E, right? So E is what? The margin of error. So again, mu plus E, mu minus E, okay? So what we can find is, again, with this here, we find this region here. So 160, based on these numbers here, based on these parameters, right? We find that the region is 150.2 to 169.8. So therefore, this is called the acceptance region. The acceptance region is between 150.2 and 169.8, right? That's the acceptance region. Outside the region, and the tails, meaning the tails that are the shaded areas up here in this graph, that's called the critical region. So essentially then, the decision rule, if X bar is in the acceptance region, you accept HO. If X bar is in the critical region, you reject HO. Okay? So that's what we want to talk about. Okay. So what I'm going to do is I'm going to stop here. We're going to take a break. I'm going to come back We'll do a couple of introductions again, and then we'll come back to this. I've got another few slides to go. I've got a document I want to show you, and then we'll do a couple of problems today. So we're not going to do just one practice problem. We'll do a couple of practice problems to get you situated. This is definitely, hypothesis testing is an area where you need to stay up with the work every day, because what we do the next day relies on what we did the day before, even more than what we've done before. So again, people, if you're watching this on Zoom and watching the recordings, it's going to be critical that you keep up with this material and don't wait till the end. Again, we're going to have some other things to do for some, a lot more online quizzes and some of the key points of the day things to get us through. Okay. All right. So I'll see everybody in about 12 minutes or so, and we'll continue this. Welcome back, everyone. Thank you, everyone, for coming. We'll do another introduction. Bo, we'll have you go. Nice to see you arrived to China safely, and that the trip was hopefully non-eventful from your last week. That was great. So why don't you introduce yourself to us?
Hi, can you hear me?
Yep.
All right, my name is Bo, and I'm a rising sophomore in questrom. Probably gonna study finance and business analytic, but I'm not sure yet. So looking for 3 facts of myself.
Yep. Go ahead. Yeah. Your video is going in and out. But if you want to, again, we know what you look like now. If you want to take the video off, it may just be easier for you.
Oh, okay, sure.
Okay. Yep. So tell us what your again. Tell us about your family. What does your family do?
Okay, so my dad, it's complicated. Like both of them retire right now already.
Cool.
My mom was a agent for a TV star, like in like 20 years ago.
Cool.
And my father is right now he's a painter, a Chinese traditional painter. He was
painter
a musician.
as like an artist painter.
Yeah, like an artist.
Cool.
And he used to be a musician. Used to be a singer on stage.
Wow. Yeah. That's quite an interesting family background.
Yeah.
Okay.
Yeah. So like, yeah, they're really kind of just So
are you and Mijian? Are you guys, your roommates here at BU? Are you live close to each other back in China or no?
Oh yeah.
Oh, you do?
We so I live in Beijing and he also lives in Beijing, and we're probably just like 3-5 miles away.
Oh, I see.
I think.
Okay, cool.
Yeah.
That's cool. Okay.
So yeah. Mm-hmm.
So tell us about some of the tell us 2 truths and a lie.
2 truths and a lie. So first is that I'm really good at escape room, and I'm a escape room player that won awards for fastest time.
Wow.
And second is I performed at Carnegie Hall and Lincoln Center, and performed a solo on Carnegie Hall.
Wow.
And the third is that I used to be on stage a lot back in China on TV.
Oh my gosh, a real celebrity. Well, again, if I guess if your mother was an agent, then you probably have a little of an in there, so that's great. So all right, so which one's the untruth?
The first one.
Which is what?
The escape room one. Yeah, I just made it up.
Escape room. Okay. So what did you perform? Are you a musician or were you a singer?
I went to high school in Jersey.
Oh yeah.
In New Jersey. Yeah.
Yeah.
So we have like all these opportunities like to go to like Carnegie Hall and Lincoln Center to perform. And then like so basically it's like we're selected as talented, musicians and all that, like, in high school. So like we got the opportunities to go on stage and perform with some of the Broadway stars.
So what were you playing an instrument?
No, I was ensemble.
Cool. Good for you.
Yeah.
That's quite an accomplishment. That's definitely something very interesting to talk about.
Yeah, it's really interesting. Like really just standing on the stage makes me like really proud, because like that's like something that I could never get.
Right.
Yeah.
Yeah. So for those of you, again, that may not be American, I mean, Carnegie Hall is a very big performance hall. Is that in New York or is that in DC?
Yeah, it's in New York City. Both
New
of
York
them,
City.
actually.
Yeah, both of them.
Yeah.
So that they're a great performance, you know, very well known. So that's great. Wow, that's really cool. Interesting. Very interesting. Well, that's great. Well, good. Well, thank you very much for sharing. Appreciate that. And I know you have issues sometimes with your video, but I appreciate you coming for that. So that's great. So thank you very much. Anybody else for today? Again, we kind of missed a couple of people today, so we have some openings. No one? Okay. All right. So we are gonna. So again, we're gonna try to get these done this week. So we're doing a bunch of them tomorrow as well. Okay. So let me go back to my screen share to continue with our discussion about. Let me bring my PowerPoint up. Where is that? There it is. Okay. So again, we're talking about HO and H1, whether or not to prove something, and we're going to talk. We're actually going to learn two different ways to do hypothesis testing. So we'll learn one way today and learn about another way tomorrow. Okay. So, for instance, now I'm going to go over this all in a minute, but there are several ways you can do a hypothesis testing. So a hypothesis testing, you'll notice it here, is the HO. Right, so HO and H1, the top one is a less than or equal to, the bottom one is a greater than. So this is what's called a one-tailed test, right? So you're basically, your alpha is on one side, okay? The total alpha is on one side. It is not always a two-tailed test where there's alpha on both sides. It could be just off on one side. So basically, we're trying to look at the upper tail test, or it can be what's called a lower tail test. It could be the other way. And notice how the HO and H1 kind of change here as far as the signs, right? The greater than or less than signs, okay? And then the last way is whether or not it is a equal to. So this would be a two-tailed test, whether it's different, okay? So I'm going to go over those slides I went over very quickly, but I'm going to go over them another way in just a second. I'm going to go through these couple of slides, and then I'm going to go to my document camera. Okay. So if you're thinking that it's greater than, you do an upper tail test. If you think it's lower, you do a lower tail test, right? So it depends. So whether you set up a one-sided test or a two-sided test depends on whether the logic of the situation. The logic of the situation dictates whether or not it's a one-sided upper or lower. Again, the burden of proof is H1. Notice how that's bold. And the benefit of the doubt is HO. Okay. So what I'm going to do is these slides here that I just talked about and kind of went over very quickly, I'm now going to go to my document camera, and I think it'll be a little easier to understand. Okay. And then we're going to do this self-check here in a second. So let me stop sharing. Let me bring up my document camera. Okay. Now, on the website, there is a document that says hypothesis testing rules of the wet road, or hypothesis testing rules. I put this together. I think this may be a little easier to understand. Okay. Now, essentially, there are only 4 rules. So this is rule number 1. So this says right here, the following are some rules that apply to most hypothesis testing scenarios across many industries and courses. Variations may apply. These rules apply to this course. So I'm telling you specifically how to do hypothesis testing for this course. Rule number 1, hypothesis testing always deals with a population. So your hypothesis statement will either deal with a mu or a p. So therefore, when you do HO and H1, it's going to be mu blank, or HO H1, P blank, P blank, right? You never do HO for X bar. You never do HO for M. You never do HO for K. You don't do HO for Z. You don't do HO for anything other than mu or P. You would never do a hypothesis testing around X bar because that's doing a hypothesis around a sample. That doesn't make any sense. You're basically trying to make sense of something from a sample to make an assertion about the population, never about the sample because you have the sample. That's rule one. Rule one's always about a population, so it's a mu or a P. There's only 4 rules, right? So we've already done one already. The second one, essentially, this is basically a review or a repeat of the PowerPoint. Just another way of looking at it. The equal sign will always go with the null hypothesis, HO. So therefore, there are only 3 different hypothesis statements for either a mean or a P. Remember, I on the previous slide, right? I said it deals with either a population, so it's going to be mu or P. So there are 3 hypothesis statements for mu. There are 3 for P's. There's only 6 total. Okay, so and I'll zoom in just a little bit here. Okay, so basically what you see is you have a hypothesis. HO is equal to 100. HO not equal to 100. Remember, the equal sign always goes with HO. So it will never be mu not equal, H1 equal. No, equal sign always goes with HO. Okay, so therefore you do this. Now this one here, right, if it's an equal sign, is a two-tailed test, which means your alpha is this area that's right here. The significance level is that area in red. This one, again, less than or equal to, notice the equal sign, less than or equal to 100. Therefore, mu is going to be, H1 is going to be mu greater than 100. The third one is mu greater than or equal to 100, then H1 is mu less than 100, right? So in this one here, the significance level or the rejection region or the critical region is to the right. This one here is to the left. Okay? Now again, if you change the mu's to p's, this would definitely have to be a proportion, like 88. So p equal to 88, p not equal to 88. P less than or equal to 88, p greater than 88, 88%, 0.88. P here, right? Same thing. So basically there's 3 mu's and there's 3 p's. That's all there is. There's only 6 of them. Okay. Like I told you before, draw the graph. Okay. All right. So this is easy because if it's an equal, not equal, it is always what's called a two-tailed test. There's going to be a shaded region over here and a shaded region over here. Now, these ones here, sometimes students get a little confused about how to draw the graph. I'm going to show you the easy way. It's very, very easy. What you do is you look at HO. You look at H1. H1 is the greater than sign, right? If I make that greater hand sign and I turn that into an arrow, ba-ding! The arrow is pointing which way? It's pointing to the right. So therefore, the shaded region is to the right. Over here, if I look at H1 and I turn that sign into an arrow, ba-ding! Makes an arrow going to the left, right? So you'll never get it wrong. Sound effects are optional. You don't do the sound effects if you want. But again, understanding where the arrows goes will help you. Again, this is always true, right? This is just like that silly rhyme about the T. If sigma's unknown, use the T. If n is larger, go back to the Z. Those are always true. Okay? And this is rule number 2. Therefore, then, we go to rule number 3. Rule number 3 says what is being asked or alleged in the question refers to H1. What is being asked refers to H1, not HO. So you determine the alternate hypothesis and then back into the null hypothesis, right? So in other words, if I have a question, I'm going to do HO and H1. I'm going to do mu greater than 100. Then I'm going to back into, then I'm going to write mu up, less than, up, equal goes with this one. Then I do that, right? So I do this one first and then back into HO. That's always a good way to do it. So you write the alternative hypothesis first, then back into the null hypothesis. You read the question carefully. Blank, blank, blank. Is there evidence that the true mean is less than? Right? Is there? So if it's less than, that clearly is that sign. Well, according to this rule right here, the equal sign goes with the null hypothesis. So therefore, if you see this wording, less than is by itself. So there, the greater than or equal, that must be HO. This has got to be H1. So therefore, it is always asking about H1. This must refer to H1 if you follow rule number 2 about the equal sign. Make sense? Okay. The last rule. Phrase your answer conclusion in terms of a null hypothesis. As I said, we either reject HO or accept HO. Also known as, you could also say fail to reject. Right? Fail to reject HO and accept HO are the same thing. Again, if you're using the analogy like we did for the judicial system, guilty and not guilty be the same way. So be reject, fail to reject, or accept. Again, I tend to use accept a lot, but that's okay. You are testing something about the null, nothing else. Again, you phrase the answer conclusion in terms of the null hypothesis. You're testing about whether it's something about the null, nothing else. You want to know if those refrigerators weigh 160 pounds or they don't weigh 160 pounds. You're not testing whether, oh, it's not 160, is it then 152? That's a separate test. Okay? Okay. Excuse me. This right here is the official answer, meaning if for some reason somebody was asking you, hey, you're a smart statistics student taking a course at BU, I would like to quote you in a magazine. I want you to do this hypothesis. What would you say the answer is? Well, you will never need to write this. I will never ask you to write this answer. But if you know how to do it, it will help you answer the questions about the conclusion. Right? So really what you do for this, and I'll see if I can get this a little bigger, right? Your official answer is you say something at the blank significance level, 0.05, 0.10, 0.01, whatever. You say, if you reject HO, you say the word is. If you're saying accept HO, you say the word is not. So at the 0.05 significance level, there is evidence that the true mean or proportion, again, this is rule number 1, right? The true mean weight of these refrigerators is not whatever HO is. In this case, I said 160 in my example, right? So if we're saying that the refrigerators are not 160 pounds average weight, we would say at the blank significance, 0.05 significance level, there is evidence that the true mean for these Parker refrigerators is not 160 pounds. So accepting HO is what's called a double negative. It's awkward. It's not the way we talk, right? Right? So you're saying there is not evidence that it is not. kind of awkward, right? Again, double negative. There is no way I am not going out tonight. What does that mean? It means I'm going out. There is no way that I am not having pizza for dinner tonight. What am I having for dinner? Pizza. Mom, there is no way I am not going out hanging out with my friends tonight. What does that mean? It means you're sneaking out of the house to go hang out with your friends. Right? It's a double negative. We don't talk that way. It's not very common, but you could. Okay? So those are the 4 rules. To review. Right? Rule number 1, always deals with population. Always. Very simple rule. Rule number 2, equal sign always goes with a null hypothesis. That's HO. So therefore, you get this, or you can replace the mu's with the p's, right? 0.88, 0.88, et cetera, et cetera. So there's only 6 ways. Okay? Rule number 3, right? What is being asked or alleged refers to H1. So therefore, you do H1 first, and then you back into and write HO. Okay? And the last one, answer your conclusion in terms of the null hypothesis. You're testing about that, nothing else. Okay? Okay. As I mentioned, you guys all did a really good job on exam 2. Very impressed. I'm here to tell everybody in this course right now that it is possible for anyone in this class. I don't care what you got in your first 2 tests. It is possible for anyone to get 100 on the final. The final, it's going to be no harder than a typical final we have in this class. You'll need to think about it. It is the final. It is the final, after all. It's not a regular test. It's the final. Now, again, the exam is not cumulative, so the final is going to deal with hypothesis testing, right? So we're going to talk about hypothesis testing and the means. That's today. Tomorrow's hypothesis testing and proportions. Then we talk about this thing called errors, which is a huge topic. Errors. We're going to talk about that on Wednesday. And then we go to 2-sample testing. Then we go to paired data testing. Then we do a couple other distributions known as the chi-square goodness of fit, chi-square test of independence, right? So we get all these different types of hypothesis testing to do, and then essentially that's going to be it. But all these different things. Okay. Those 4 rules I just showed you. Follow those rules. If you want to get 100 on the final, you will follow those rules religiously. There are no exceptions. Right? If you follow those rules, you'll get it right every time. Okay? Certainly in this portion of the class, I'm going to give you some help, and I'm going to show you how to do things. If you follow the way that I do it, follow my rules, I virtually guarantee you'll do very well on it. I'm going to put myself on a limb here. In the past, I've had students come back to me and go, "Oh, I didn't do as well as I thought. I got an 85 or an 80." And I'll go over their problems and I'll go, "Okay, well, what, this problem here, you didn't follow my rules." "Yeah, well, I really thought." No, yeah, I thought. No, follow my rules, period. There are no exceptions. Okay, that will definitely help you. Okay, so now what I want to do, we're going to do a couple of problems. So let's do, we're going to do the problem that's associated with the PowerPoint, and then we're going to do the first 2 homework problems that are set for tomorrow. So we'll do those, and that'll be some good practice to get you ready and on the way. Okay. So let me screen share with you. Okay. So here's our, we're going to do this problem. Then I get 2 other slides to show you, and then we'll do two other problems. Okay. So do this problem. First. There's 2 problems here. Sorry about that. All right, we're going to do the first problem. The second problem is actually a proportion problem. We're going to talk about that one tomorrow. Okay. All right. You work for a clothing company and are interested in the average weight of men 18 to 30. You sample 64 men, there's your N, in the age group, and find the average height to be 70 inches. That's your X bar. The standard deviation is known to be 3 inches. Again, it's known to be, so it's sigma. Is there evidence at the 1% significance level, 1 minus alpha, that the average height of men, blah, 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 above 69 inches? Okay? All right. So basically what we always want to do, we're going to learn there are 4 steps. Step number 1. Step number 1 is define your hypothesis. So therefore, this is HO and H1. Notice how I wrote HO and H1 with a colon, right? So again, we go back over here. We told you it's either going to be rule number 1, it's going to be a population proportion or a population mean. We have X bar, so therefore we're talking about a mean. So we're doing mu, mu, okay? So again, it's going to be mu, mu, okay? We want to know whether or not, right, the question's asking, is there evidence at the 1% significance level the average height of men is above 69 inches? So 69 inches must be what we think the, whether that's going to be our alleged mean. So it's going to be 69 here and 69 here, right? So if it's 69 here, 69 here, 80 here, 80 here, 102 here, 102 here. These numbers are always the same. It's not like one of them is 88 and the other one's 87, or one of them is 29 and the other one is 30, right? They're always the same value. If this is 22.1, this is 22.1. 15.69, 15.69. They're always the same number. Okay. What does Rule 3 say? Rule 3 says, is there evidence that it's above 69 inches? Above is what? Above is greater than. So that means we know this is going to be less than. Rule number 2, equal sign goes with the HO. Great. We're on a great start here. Step number 2, right? We're going to define our decision rule. Our decision rule is reject HO if, again, you always write reject HO if. Okay, and we're going to say if what we want to look at is clearly we know what sigma is, right? So either we're going to use it as a z calc. So we're going to reject HO if what's called a z calc. Z calc means your calculated z, right? If your calculated z is what? Same thing as this, is greater than some value, right? Where our alpha is 0.01. So again, looking down here, right? Here's our X line. This is 69, right? We want to know this region here is 0.01. What we're trying to find out is, we want to find out whether 70, whether it's over here or over here. If 70 is here, we accept HO. If 70 is over here, we reject HO. So to make this decision, we are then going to use we're going to use our z-chart, where this is 0. Again, this area here and this area here are equal to each other, right? And we know this is 0.01. This is also 0.01. So we're going to reject HO if our z-calc is greater than, if this is 1%, right? So look at this over here. If this is 0.01 on the z, that means this is 0.4900, okay? If I go to my z chart, right, I look for 4900. It's right here, which is 2.33. So therefore, what I do for my decision rule, I reject HO if my z-calc is greater than 2.33. My step 3 is we're going to calculate our test statistic, meaning we're going to do our z-calc. Our z-calc is x bar minus mu all over sigma divided by square root of n, right? It's our standard error because we know we have what? We have a sample over here, okay? So our x bar is 70, so 70 minus the alleged mu of 69, so 69 all over sigma. Sigma is 3, n is 64, square root of 64, okay? So 70 minus 69 is 1, 3 over 8, right? So 3 over 8, okay, let me do something, I think. 3 divided by 8 is 1 over 0.375. So therefore, 1 divided by 0.375.
Professor, you can't see the...
Yeah. Right. So 79 minus 69 over 3 over 64. 3 over 3/8 is 1 over 3.375. Is what? 2.66, I think.
Yes.
Okay. So this value here is 2.33. 2.66 is here. So that's in the rejection region. So we're going to reject HO. So your conclusion is, again, reject HO. It says, is there evidence that the average height of men is above 69? So this HO is just less than or equal to 69. So clearly it appears it is greater than 69. So reject HO. There is evidence that the average height is not less than or equal to 69, right? Reject HO, there is evidence that the average height is not less than or equal to 69. Again, I'm answering my question in relation to HO. We'll do this one tomorrow.
Professor, I have a question.
I have an answer.
So why is it 4.49? Why are we calculating? Like, how did you get 0.4900 to calculate?
4900?
Yeah.
Right, because we know we're told up here we know already, right? Watch this. So we know this here, 1. We know that it's an above 69, so we know is a one-tail test. Ba-ding, right? We know that the answer is the graph. So we know on this graph here, this area here is to the right. This is going to be 0.01. Due to symmetry, this is 0.01. This is 50%. So 0.01, this is going to be what? 49%. So therefore you got to look up 49,000 on the body of your table.
That's right. Yeah.
Okay?
Yep. Thank you.
All right.
Professor,
Student?
can you really quickly explain again why, since 2.66 is within that last 0.01 region, we reject the hypothesis?
Right, because basically what you're going to do, you said your answer here is reject HO if your Z-calc is greater than 2.33. We found the value to be 2.66. That's greater than 2.33, so therefore you got to reject HO.
Okay,
right?
thanks.
So down here, again, here's my 0 point. Here's my cutoff of 2.33. 2.66 is clearly in this region here.
So when would be an example of when we use the upper level?
Say again, example of what?
Of when we use the upper tail, oh no, the lower tail test?
Yeah, we'll do several of those in a minute.
Okay.
So, Professor, is that when you mentioned there's evidence that the average height, is that the fourth step, or are you going to go over the fourth step later?
No, the fourth step's this one here.
Oh, okay, got it.
Right. So this whole thing is the first step. This thing here is the second step. Calculating your test statistic. The test statistic is 2.66. So all of this is that thing, and then your conclusion is this part.
Got it, thanks.
2.66 is greater than 2.33, because in this area right here, right? That's where you're going to reject HL.
Sure.
Let's do another one together. I'm going to do it the exact same way, and then you'll kind of get a little bit. So let me go. So the first one you're going to do for homework tonight that we're going to do together is this one. Okay. The purchase of a coin-operated laundry is being considered. The current owner claims that over the past many years, the average daily revenue has been $675. Let me do that color is not dark enough. Let me get another color. That's been $675 with a standard deviation of $75. And again, that's sigma, right? So we know mu is 675, sigma is 75. A sample of 30 days revenue, so your N is 30, right? Reveals an X bar of 650. Is there evidence at the significance level of 0.01, so alpha is 0.01, that the true average daily revenue is less than what the current owner claims? Okay, I don't need to worry about that yet. My first time through the problem is I'm trying to identify all of the variables, and I've done that here. So now step one is write your hypothesis statement. So step one, HO and H1, right? We know it's going to be a P or a mu. It's going to be a mu. So it's a mu and a mu. The alleged mean is said to be 675. So it's 675 and 675. Okay. Now again, I did HOH1, I wrote mu, I wrote the value. I've left the inequality, if you want to call it. I'm doing this last, right? So basically what I do is now I read the statement. Is there evidence that the true average daily revenue is less than? Less than is less than. So this must be what? H1, rule 3. So this means this is less than, means this is going to be greater than. The equal sign always goes with HO. There you go. So now I've done my hypothesis statement. My step 2 is my decision rule. reject HO if, now again, we're either going to use a T-calc, Z-calc, or something else. Certainly for this one, we have sigma. We're going to do a Z-calc. Okay, so let's draw my graphs. So the first one, right, my mu is 675, right? We know, ba-ding! We know it's a lower tail test. We know that this alpha level is 0.01, so this is 0.01, right? And we're trying to find where is 650. If 650 is here, that's accept HO. If 650 is over here, that's reject HO. To solve this, we're going to use the Z-curve. This is 0. This is 0.01. There's also this level here. This is also 0.01, right? So we're going to make our decision down here and then write our conclusion up here. Okay, so reject Z-calc if our Z-calc is less than a negative. Remember, these are positive numbers, these are negative numbers. If this is 0.01, that means this is going to be 0.4900, what Ryan was asking. It's going to be the exact same number, right? So again, I find the value of 0.4901, that's the closest value I have, is 2.33, right? It's the intersection. So 2.33. So therefore, reject HO if your Z-calc is less than negative 2.33. Your step 3 is calculate your test statistic. Okay? So that's going to be your Z-calc. So Z-calc, you've already done this before, is x bar minus mu over sigma over radical n. So in this case, it's going to be your 650 is your x bar minus your mu all over your standard error. Sigma, 75, square root of n, square root of 30. That's negative 25, which is fine because you want a negative number anyway, right? This is negative 2.33, by the way. Negative 25 divided by 75 square root of 30. Hold on one second, I actually have that. Right, did have that. One second here. It's 75, it's negative 25 over 13.69, which equals negative 1.82. Negative 1.82 is all the way, that's here, right? So clearly that is accept HO. So your step 4 is accept HO, semicolon, right? There is not evidence that the true mean revenue of laundry is not, again, double negative, there are not evidence that the true mean is not HO greater or equal to 675. This thing is officially your answer.
Excuse me, Professor, I have a question.
What's your question?
Could you really quickly explain how you got the z value of negative 2.33 again?
Yep.
Thank you.
Right? If this value here is 0.01, we know this whole thing by symmetry is going to be 50%. So if this is 0.01, that means this area here is going to be 0.49, right? 49.01 is 50%. So therefore, I look up 0.4900 in body of table. Okay? So again, you have to look in the chart here. I'm looking for 4900. 4900, the closest I can get is 0.4901. Now remember, 3 rules. Take the closest value if you can't find it exactly. Well, 0.4901, that's the closest value to 4900, which equates to 2.3 and then 3. Right? So therefore, this is going to be on the Z chart. This is 0. This is negative 2.33, or this is 0.01.
I think that makes sense now.
Okay, let's do another one just to make sure everybody knows. If I do this one, right? If I do this, if I know this is 0.05, that means this area here is going to be 0.45, right? Because this plus this is going to equal 50%. So again, I look up 0.4500 in the table. Right? 4495, 4505, that's that special value. That's the one I told you for rule number 3. That's going to be the value of 1.645. So therefore, this is going to be 1.645 on the Z chart. Right? So that value there, this is negative 2.33 on this one, where this is 1%. This is 1.645, this is 0.05. We got it? Questions are good. Okay. Any questions on this problem?
Yeah, hi, Professor.
Yeah.
Why we must use 2 negative? I mean, there is 2 no in this sense, but not just 1 positive statement for the answer.
I didn't hear you. Why must we what?
Why we must use 2 negative?
Oh, again, that's just that's again, that's the official answer. Again,
Yes.
typically, again, when we do problems like this, we will go through the answers, and I will have that for you. Right? Again,
Okay.
so we accept H. So essentially, you're going to say accept HO. Yeah, it doesn't appear that the true average is below what is. It's not less than what he claims. Right? Again. Right? The true daily balance is not less than what the owner claims. Essentially what you would do. I'm going to talk more about the conclusion in subsequent classes. We'll talk more about it tomorrow too. Okay? Let's do one more problem.
Yeah, okay, thanks.
You're welcome. All right, let me find my other problem here. One second, I got a mass of papers on my desk here. I gotta look for what I'm looking for here. Here it is. Okay. Again, this is the second homework problem for tonight. See if we can do this one. Suppose that GMAT scores are normally distributed with a mu of 500 and an S, a sigma of 100. If we randomly sample 20 students, that's my N, this is my mu, this is my sigma, who are applying to Harry Potter College, and the sample mean is 537, that's your X bar. Is there evidence that GMAT scores of applicants at Harry Potter College differs from the mean of all GMAT takers? Use alpha of 0.10. Now again, I went through this problem quickly. My first time through, I'm not really trying to understand the problem. I'm trying to write all the different variables. So I'm gonna write that off to the side. So my mu is 500. My sigma is 100. My N is 20. My sample mean, X bar, is 537. And my alpha is 0.10. I do my hypothesis statement. So again, like actually we could draw my graph here. My X line. This is 500, right? What we want to know is we want to know whether it differs from the of all matters. So differs, is that less than, greater than, or not equal to? Clearly it's a not equal to, right? Because it could be greater than 500, less than 500. So this is going to be a two-tailed test. Okay, so that means on the Z, it's also going to be a two-tailed test. Okay, all right, let's do HO and H1. It's going to be mu, something about 500, something about 500. Differs, we said is not equal. Okay, that's great. So then we do, that's your step one. Your step two is your decision rule, right? It's going to be reject HO if zcalc is greater than some number or less than another number. So basically it's going to be this greater than this number or less than this number. Now it's going to be symmetry. So if this is 10%, this is always the total alpha. So these two areas I'm hitting with my pen are a total of 10%. So this is 10% divided by 2, or 0.05, which means this is 0.05. So as I just did with the last example, right? If this is 0.05, or 0.05 here, this is 0.4500, that's that value that's on the Z chart, 0.44954505. That's that one that's what? 1.645. So this is going to be 1.645. This is going to be negative 1.645. Again, it's going to be symmetric. So this is greater than 1.645. This is negative 1.645. Our step 3 is to calculate, our test statistic, right? So that's going to be 537 537 minus 500 divided by 100 square root of 20. I know what that is. I know that's 1.64, 1.65. So 1.65 is just a little bit, but it is officially, it's in that shaded area. So you're going to reject HO. So your 4 conclusion is reject HO, right? What's the question? Is there evidence that the mean GMAT score of Harry Potter applicants differs? Yes, reject HO. The mean GMAT score differs. Questions?
I have a question.
Yep.
If one of the conditions satisfy, you conclude that you reject it, right?
If one of the conditions satisfied, say that again.
So, like we got 1.65 greater than 1.645. We don't need it to satisfy the smaller than negative 1.645.
No, because when we say this differs, we're saying, again, it just means is it differs either way. So is it below or above the average of 500? Because difference could be greater than 500 or less than 500. We happen to be in upper tail, so that's just fine. But still, it's still a two-tailed test. On an exam, if you only wrote this top value here, reject greater than 1.645, you get this question wrong. Okay.
Okay.
All right. Before we go, I'm going to go back and share my screen with you. Okay. So what we also can do, back to the PowerPoint, right? Thumbs up, everybody sees the PowerPoint? Thank you. So basically what we can do, we just did this for sigma, where sigma was known, and we used the Z curve, right? If sigma was not known, we would then use the T curve, right? To the T curve. So S would replace sigma, and the T would replace the Z. So we could do the exact same thing. Okay, so that's how you would form the test statistic. Okay, let me go back and show you. With this problem here, if indeed they said that this was mu of 675, if this right here, this says sigma equals 75, if this said indeed it was S equals 75, now everything stays the same, but now your test statistic is no longer a Z calc, it's a T calc, right? Because sigma's unknown, right? So this would become a T calc, right? Where this is x bar minus mu S over radical n, right? So you get the same value, right? But the issue is this would be totally different, right? So what you would have to do is you would have to look up the value on the Z chart, on the T chart. So for instance, right? We know our alpha is 0.01, okay? So what we do is here, is again, we use this area these three lines that we didn't talk about before. So again, so is this a one-tailed test or a two-tailed test? It's a one-tailed test, right? One-tailed test. Okay. So therefore, what we can do is significance level for a one-tailed test. What is it? What's our alpha? This is 0.10. Our alpha is 0.01. So we're going to use this column right here, and we're going to go down. Again, our degrees of freedom in this one are 29 because n is 30. So our degrees of freedom are 29. Okay. So then what I would do is I would use this column right here, 0.01. I go down, 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 down. Right? Find 29 degrees of freedom. That value is 2462. Okay? So in our original one, this was 2.33. Now, if I use the T-chart, it's going to be 2.462. Okay? Now again, it doesn't change our answer. Our answer is going to be the same, but this is officially a T because now what we've done is an S. So what we've learned today was we learned the four-step method of doing hypothesis testing. Four-step method, right? HO and H1, decision rule, calculate your test statistic, and conclusion. Okay? But we've learned today we can do it both for means of, a known mean, meaning mu, where you have a known standard deviation, or we can also do it, I just showed you how to do it, again, do a T-count. Okay? So, for the homework that you're doing for tomorrow, again, I've already done the first two problems. We will repeat those again tomorrow. We'll repeat problems 84 and 85 again, and then we'll do 86. I think it goes through to 90, right? So we'll do those problems. Some of them will be using the T-curve. Some of them will use the Z-curve, and we'll do them all out the same way. Four-step method is going to take us a while, okay? So tomorrow, this is brand new for most of you. It's going to take a while for you to get it. Fine. Tomorrow's lecture is literally 4 slides. So tomorrow's lecture is going to be less than 10 minutes, and it has to do with proportions. Very easy. So again, if you understand the homework tonight into tomorrow, then understanding proportions is going to be, oh, I get it, no problem, right? So that'll be very easy. So I know tomorrow's homework is going to take us a while. Now going forward, you can see how long it takes to do these homework assignments, right? Because this 4-step method took us almost 10 minutes to do every problem. We may not have time to do all the problems, right? So I'm going to do enough problems where I feel it's sufficient for you to kind of grasp the concept. And again, you can then check the ones I don't do. Either you can come to office hours and I'll do them, or you can certainly check your answers for the answer key that I'll be posting, right? So again, depending what you have. So again, so because from now on the problems take a little bit longer, we're not going to have time to do 20 problems. It'll take all hour and a half. So I just can't do that. So I will do the ones that I feel are important, and then the other ones you can do on your own. Okay, but just because I don't do all the problems doesn't mean you should do all the problems. You should do all the problems. Okay, any questions? All right. So long, everybody. If you have any questions, stay on. Otherwise, we'll see you all tomorrow. Thank you. Enjoy your day.
Thank you, Professor.
Thank you.
Goodbye, Professor.
So long.
Professor, yeah, I have to say